Hi again, physics class. Short topic today. I'm just going to talk about orbital speed or orbital velocity. And we're going to finish up our Kepler stuff. Now, Kepler, just to remind you, he's a mathematician. He worked with Tycho Brahe, did an incredible job crunching numbers, came up with his three laws. Now, his three laws came from data, just noticing patterns, which is different than laws that come from first principle. Okay, so Kepler knew all about planetary motion. His third law is amazing, relating period and orbital radius. Okay, but it doesn't explain why. It's purely a description of what is happening. Okay, and that is an important distinction. So Kepler, he believed that magnetism was responsible for planetary motion, which I think us as modern people doesn't make much sense, but it could work. An attractive force does cause all of this. Magnetism can be attractive. It would have made sense in 1600. Okay, it wasn't until Isaac Newton in the 1660s, 1670s, he formulated the law of universal gravitation. He determined that gravity was responsible for the motion of the planets, and he proved that Kepler's third law was valid from first principle, just from the principles of gravity. Okay, so Kepler came up with his law kind of from the top down, from observation, and Newton proved it from theory, kind of from the bottom up. So that tells you that Kepler's third law is very, very powerful, and he did a great job. All right, now let's talk about gravity and orbits. So gravity causes objects to orbit. We're going to call that circular motion. Most orbits, particularly the Earth, all the inner planets, very, very close to circles. So we're going to say that Fg is the cause of this motion, so it is a centripetal force. All right. So I've drawn something, I've brought some old formulas back. This is universal gravitation. So I've drawn two masses, say this is the Earth and the Sun, M1 and M2, separated by distance r. M1's going to go all the way around a circle of radius r. It experiences this centripetal force, mv squared over r, caused by gravity, this force. Now I want you to notice one of these m's cancels, and it's the mass of this thing, the small guy, what is orbiting. One of the r's cancels as well. So what we end up with is gm over r equals v squared. This is an expression for orbital speed. I'll clean it up. It's really nice. Okay, m, you'll have to remember this, is the mass of what is being orbited. So if we're finding the orbital speed of Earth, we would use the mass of the Sun. If we're finding the orbital speed of the Moon, we'd use the mass of Earth.